Hey folks, today we're going to solve a system of equations that has a quadratic equation as well as a linear equation. So as you can see here, f of x, this is our quadratic equation right here, and this is our linear equation right here. So let's start out by graphing the quadratic equation. The quadratic equation, what's that going to look like when we graph it? That's right, it's going to look like a parabola. So in order to graph this parabola, we're going to have to find out some information about this. So I'm going to think of this as y equals, because f of x equals and y equals same thing. And so in order to graph this, I have to kind of take a look at it. And what do I know about this? Well, I know that it has a y-intercept down here at -12. It's kind of off my graph. I don't know how helpful that will be. What else can I figure out about this thing? Well, let's try to factor it and see if we can come up with some x-intercepts. The first thing I'm going to do is take that negative out of the front. I do not like to have a negative leading coefficient. All right, when I take out that negative, I have x squared plus 8x plus 12. When I factor that, looking for things that have a product of 12 and a sum of 8, I can see that that's going to be x plus 6, x plus 2. And if you don't believe me, you can do 6 times 2 and you get 12. You can do x times x and you get x squared. And then when you do the outside inside of your foiling, you have 2x plus 6x. That gets you this 8x here. So I got that right. Don't forget that negative on the outside. So this tells me that my x-intercepts are going to be -6, 0, and -2, 0. So all right, so on my graph I have -2, 0, -6, 0. I'm going to erase all this work just so that I have some room to see what I'm doing here. I probably shouldn't have done my work right on my graph. So I got my x-intercepts. I got my y-intercept, which may or may not help us. And now I need some additional information about this parabola. Well, probably the most important point you could use in a parabola would be the vertex, and we're going to find the vertex by first finding the axis of symmetry. As you may recall, to find the axis of symmetry when we are in standard form, we're using the equation -b over 2a. X equals -b over 2a will give us the equation of the line, which is the axis of symmetry. The axis of symmetry, as you recall, is going to cut the parabola right in half. And so, all right, the b term is the 8, so we're doing the opposite of -8. Over 2 times -1. This is going to be our equation. So we're going to end up with 8 over -2. So our axis of symmetry is going to be x equals -4. So our axis of symmetry, if I knew how to use color, I would make it a different color, but I don't. Color's not my thing. So there's my axis of symmetry. So the parabola is going to be a mirror image on either side of this axis of symmetry. And I know the half of the vertex. My vertex is going to be -4, comma, something. So what's the something? Well, to figure out the y value when I have an x value, I simply have to plug the x value back into the original equation and see what I get for y. So I'm going to do my work up here. So my y is going to equal the opposite of -4 squared. This is going to be yucky to begin with, but it'll clean itself up pretty quickly. -8 times -4 minus 12. So this is -4 squared is 16. Slap a negative on it, it's -16. Minus -4 really means +4. And then a minus 12 at the end. -16 plus 4 is -12. When I subtract, I screwed up. I'm sure that I wrote it, but somehow my 8 disappeared over here. So this is really 8 times -4. So this should be a positive 32 over here. Okay, that's better. So -16 plus 32 is 16. When I subtract 12 from that, it's 4. So what did I just figure out? I just figured out that my y equals 4 when x equals -4. So -4, 4 is my vertex. All right, and so that's pretty much enough information to graph my parabola. Remember, I had my y-intercept before. It's off my graph, but it's not that far off the graph. And since my y-intercept is 4 to the right of the axis of symmetry, I know that I have another point 4 to the left of the axis of symmetry. So we'll approximate it to be right there. So my parabola ultimately looks something like this. All right, so I got my parabola graph. The solution to a system of equations, as you recall, is a couple of different things. The solution to a system of equation, one is the numbers that you can plug in for x and y and that will satisfy both equations. It'll make both equations true when you plug it in. So the x and y that we're looking for are things that we can plug into both equations, both f of x and g of x, to make them true. The second thing that a solution for a system of equations is it's the intersection on the graph it's the intersection on the coordinate plane of each of the graphs. So we have the graph of x squared minus 8x minus 12. So now we simply have to graph 2x plus 9. 2x plus 9 is already in slope-intercept form. So we begin with the y-intercept at 9, and we go up 2, right 1. Well, that's going to take us off the graph pretty quick. How about we go down 2, left 1 instead? Down 2, left 1 instead. Down 2, left 1. 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 Now, I kind of sketched this, my parabola. My line's pretty exact here. My parabola was more of a sketch than a graph, but it looks to me like my solutions are here and here. So how do I know if I did this right? Well, I could take those two numbers and I can plug them in. I'm pretty sure that my solutions here are negative 3, 3. And negative 7, negative 5. Now I know they both work for the line because I counted them out. So to test them out, I'm going to have to plug them back into my original quadratic equation. So all right, let's see if I can do it this time without messing up. So if I did this right, 3 would be my y value, and I'm plugging in negative 3 for my x value. Try not to lose my 8 this time. So negative 3 squared is 9. Slap a negative on it, it's negative 9. Negative 8, negative 3, that's a plus 24. So 3 equals negative 9 plus 24 minus 12. So this is 15 minus 12 equals 3. Hey, that works. So I've just confirmed that negative 3 comma 3 is in fact a solution. Now we have to test our other one. So we're going to do the same thing with negative 7 and negative 5. If this works, negative 5 is the y value, and negative 7 is my x value. And if it is truly a solution, this will be a true equation. The equation will be true. Negative 7 squared is 49. The opposite of that is negative 49 plus 56 minus 12. Negative 49 plus 56. 7 minus 12 equals negative 5. Haha, that's true. So we have our equation. So the solution to this system, and we checked it to confirm, is negative 3 comma 3, negative 7 comma negative 5. Thanks for watching.